In this question, we determine the rate of change of revenue in terms of dollar billion per year using this revenue and number of employees relationship, which is given in the equation as 7 r squared equals 959 n cube. So first, I'm going to differentiate both sides with respect to time. So we get 7 times of derivative of r squared with respect to time is. First, we apply the power rule. So the derivative of r squared using the power rule is 2r. And then applying the chain rule, we write dr over dt. This is the rate of change of revenue with respect to time. And this equals 959, which is a constant. And we find the derivative of n cube with respect to time. So first we apply the power rule, and which gives 3n squared times applying the chain rule to find the derivative of n with respect to time, which is dn over dt. So we can plug in these values and determine dr over dt. First, let's simplify this. So this equals 7 times 2 is 14. It is 14r times dr over dt, and this equals 959 times 3. This equals 2877, and this is n squared times dn over dt. So we can plug in the given information, that is r dr over dt. I'm sorry, we have to find dr over dt. Dn over dt is also given, that is the rate of change of employees. We should be a little bit careful about the units, because as far as this relationship is concerned, R is given in millions and N is given in thousands. So when we use the given information, we should convert R to millions. It is given that in 2012 the revenue is 38 billion. So let's convert the 38 billion to millions. This is 38 billion. We should convert in terms of millions. We know that 1 billion equals 1000 million. This is million. 1 billion equals 1000 million. So therefore 38 billion equals 38 times 1000 million. And so this equals 38,000 million. I have converted the R to 38,000 million, and we have this 184,000 employees. That is, n has to be in terms of thousands. So it is given that n equals 184,000 employees. Since we have to consider this n in terms of thousand, we divide by thousand, and so this equals 184. So it is given that n equals 184, and or we have already determined it is 38,000 million, and the rate of change of number of employees is 13,000 per year. So this also we will convert in terms of thousand, that is dn over dt, and this is given as 13,000 per year. This is 13,000 per year. Once again, we divide this by 1000, since n is in terms of thousand. So this equals 13 per year. That is, the rate of change of number of employees with respect to time is 13, which means it is equivalent to 13,000 per year. Now we can substitute all these values into the derivative equation. Let me copy that is into this. This is the derivative equation. So I'm going to copy that derivative equation, which is 14r times of dr over dt, and this equals, on the right side we have 2877 n squared times dn over dt. Let me plug in R, that is 38,000 million. So I put 14 times of 38,000 times dr over dt. That's the thing which we have to find. So I write dr over dt, that is the rate of change of revenue. And this equals 2,877 times n. We have converted the n in terms of thousand, which is 184, and then multiply with dn over dt, that is the rate of change of employees. And this is 13. So I multiply this by 13. Now we can solve for dr over dt from this equation, that is dr over dt, and this equals 2,877 times 184 times 13. This is over 14 times of 38,000. I just observed that this 184 has to be quantity square, because we have n squared. This means when we replace n by 184, this has to be quantity square. So this will also be quantity square. And we plug this expression into the calculator, and we find dr over dt. This is approximately 2,380.17 million per year. This is a million, and this is in dollars per year, because the unit of revenue is $1,000,000. It is $1,000,000 per year. In fact, we can convert this to billion by dividing by 1,000. So we get dollar 2380.17 divided by 1,000, and this is approximately 2.38. We can ignore the other decimals. So it is $2.38 billion per year. And so this is the rate of change of revenue